Okay, everybody, welcome back. We are going to be tackling our final example problem in this section, which is really sad, but it's okay. We'll get through it. I know it's the last one, but then there's Unit 3, and we'll have more examples, so it'll be okay, you guys. All right, well, so example 2 is a lot like example 1, so if you'd like to try example 2 on your own, I highly recommend that you try it on your own. Fast forward to the end of the video and see if you get it right, which I will say on this one, there are, let me count, let's see here. There are 1, 2, 3 different ways you can do this one. So if you get done and it doesn't look like mine, maybe raise your hand and have me check your paper to see if you did it right. Because technically there are 3 ways you can do this problem. So, all right. Well, there's actually more, but there's 3 different final reasons why lines are parallel. But yeah, let's get going. Okay, so I'm given that angle 1 is congruent to angle 7. Now, which types of angle pairs are angle 1 and 7? Which one makes like the two V's kind of looking thing? Correct. Those are alternate exterior angles. So I'm given that alternate exterior angles are congruent, and I'm proving that lines are parallel. So I'm proving the converse of the alternate exterior angle theorem, which means I cannot use it in my proof. Okay, so you cannot use that phrase anywhere in this proof at all. Okay, so just watch yourself. Okay, so I'm going to have to use angle 5 and 3 to help me show that since we're talking about congruent things, it probably will be congruent, but we'll have to see. I need to use 5 and 3 to show that one of our angle pairs that we have talked about are congruent other than the alternate exterior angles. And if I can do that, that means lines are parallel. All right, well, let's get going, you guys. So we always start with the given, correct? Nice job. Okay, now I need to see if somehow, maybe if I can somehow use 1 and 7 with 5 and 3. I don't know, maybe I could go somewhere with that. So let's see. Do you guys spot anything in my picture that might be helpful to show some other properties about these angle pairs? Yes, I agree, you guys. Do you guys spot there are 2 x's? There's one right here and one right there. Which type of angles form at the x? The vertical angles form at the x. So I know that angle 5 and 7 as well. So I know angle 5 and angle 7. And I'm just going to put a slash to kind of separate them, as well as angle 1 and angle 3. Those are and symbols. So 5 and 7 and 1 and 3 are vertical angles. And how I know that is, well, that's what it means to be a vertical angle. They appear at the x, they appear at 2 lines intersecting, and they are right across from each other. So by my definition of a vertical angle, that's how I know they're vertical angles. So definition of vertical angles. All right, let's keep going. Now that I know they're vertical angles, how do vertical angles relate to each other? Holy hot dog, you guys are so bright. You guys should teach me. Like, I don't know why I'm teaching you. You know everything. So, vertical angles are congruent. So, since I know these 2 are both vertical, I know that angle 5 is congruent to angle 7, as well as angle 1 is congruent to angle 3. And I know that by the vertical angle theorem. Vertical angle theorem. Okay, so now I need to somehow use these 2 lines to show me I have a lot of congruent statements. So I need to think about those angle pairs other than alternate exterior angles that are congruent. So what other angle pairs that we talked about are congruent when we have 2 lines crossed by a transversal? Yes, so corresponding angles are congruent, as well as alternate interior angles. So, do you see any alternate interior angles or corresponding angles? Well, yes, I see multiple ones. So, if I can show, if you guys see here, which I can highlight, but it's going to start getting messy, but I'll do my best. If you guys see here, if I trace over 3 and 5, they make the Z shape, or the S. Okay, what angle pair makes the Z or the S? Yes, they are alternate interior angles, which are congruent. Okay, so maybe I can use that to show alternate interior angles are congruent. I could also show maybe, if you guys see here, 7 and 3 make the F shape, which are corresponding angles. So if I could show those are congruent, that could be another route that I take. Or I could show that 1 and 5 also, if you trace over 1 and 5, do you guys see the pink F right here? Right here? Guys, so 1 and 5 also make the F shape, which means they're corresponding. So also, if I could show those two corresponding angles are congruent, that could be another way I prove parallel lines. So there's lots of ways I can go. I'm just going to make it easy. Since there's only one pair of alternate interior angles, I'm going to go that route. So do you guys see a way using this line and this line that I can show 5 and 3 are congruent? Because if I can show 5 and 3 are congruent, and I know 5 and 3 are alternate interior angles, that means lines are parallel, which I might need another line, but we'll see. So let's see here. So I'm trying to show 5 and 3 are congruent. So let's see here. 5 is congruent to 7, 7 is congruent to 1, and 1 is congruent to 3. So what tells me that 5 and 3 are congruent? Holy hot dog, that is the transitive property. If A is congruent to B, and B is congruent to C, and C is congruent to D, then A and D are congruent by the transitive property. So that's one route I could go. Okay, and those are alternate interior angles. So I'm also need to declare that I've found some alternate interior angles. So I know that angle 5 and angle 3 are alternate interior angles. And I know that, well, they make the Z shape. That's what it means to be an alternate interior angle. So what do you guys think is my reason for me knowing that those are alternate interior angles? By the definition of alternate interior angles. Nice, you guys. Definition of alternate interior angles. Yes. So you guys, using these two lines, I've shown that I have alternate interior angles and that they're congruent, which means lines are parallel. Whoa. Guys, and since I showed that alternate interior angles are congruent, that means, remember, whenever you see parallel, I must have a converse theorem. So, by the converse, okay, I see parallel, which means I need the word converse. I have to have a converse theorem to prove lines are parallel. So, by the converse of the alternate interior angle theorem, my lines are parallel. Whoa, wasn't that cool, you guys? But it's kind of sad, though, because like I said, this is the last example of this section. But there are more sections, more units, so I will get through it. But for now, I'm a little sad. But I'm also really excited because we just did a proof. So my excitement is much larger than my sadness right now. So I'm going to put my happy face because we just did a proof, and we love proofs. So nice job, you guys.